Welcome to solverfy.
Looking at more problems on friction, consider the diagram shown in the board. We want to find out what the minimum force will be what the value will be, okay, to move that wedge in the bottom diagram to the right. So what we can do to solve this problem is to apply friction law, applicable one, friction law, as well as the conditions of equilibrium. Let's say for the top diagram, consider equilibrium in the vertical direction is going to be zero, so that we have our minus p c plus n1 to be equal to zero. Of course, pc is the compressive force and is 2.663 kilonewton. Okay, so when we do this one, we're going to arrive at n1. N1 is the normal reaction at point 1 to be equal to pc. So therefore, n1 is equal to 2.63 kilonewton. Okay, then we'll consider equilibrium in the x direction. Zero, the summation of the forces in the f direction, in the horizontal direction, is going to be zero, so that we'll have minus pr, that force that is going to the left there, plus f1, the frictional force at point 1, being equal to zero, so that we now have f1 to be equal to pr. Okay, then we can consider equilibrium of the bottom system. If we do that, we are going to have the summation of the forces in the vertical direction to be equal to zero. Okay, then the forces there are n1 plus n2, normal reaction at point 1, normal reaction at point 2, n substitute 1, n substitute 2, cos 10 degrees plus 10 degrees. Okay, minus f2, frictional force at point 2, sine theta. Of course, f2 is the same thing as mu, that is the coefficient of friction, mu na, n2. Okay, it's in mu n2. That f2 is in mu n2. Okay, sine 10 degrees. Sorry, that is sine 10 degrees. Sine 10 degrees. Okay, all right, equal to zero. So when we do that, you can figure out your n2, plugging in all your values. You're going to have n2 to be equal to 2.86. Put in your mu. Of course, our f2, as I said, this one now becomes mu. That's the frictional force. Sorry, the equation of static friction, n2. Okay, so that's the value of this particular one. So when you solve everything, when you plug in all your value, you're going to have 2.86 kilonewton as your n2. And you make it the solid of the formula. Of course, you know n1 already before. Then you can consider equilibrium in the x direction for that same bottom, the wedge, okay, being equal to zero, so that when you solve these, you're going to arrive at your P to be equal to that force, that minimum force that we want to, that is going towards the right, moving that wedge towards the right. Sine 10 degrees, okay, plus mu, coefficient of static friction, N2, cos 10 degrees, inclination of the plane of the wedge, plus mu N1. Okay, normal relation at point 1. When you do that, you're going to arrive at the answer to be equal to 2. Plug in all your values, 2.8, 2.4 kilonewton. So that minimum force that is required is 2.4 kilonewton.